Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. I've been doing a lot of asteroid work lately, and I thought I would share some of it with some of the main channels so you see what's going on over on Shamrock Banks Observatory. Now, the other day I had a session where I used the 11-inch RASA telescope, and I used the new ZWO 6200 MC color camera. And I wanted to see how it did with asteroids. I was using guiding, and I was taking 1-minute exposures. In fact, I took 60 of them. So let's cue up the music and have a look and see what I found. Now behind my head, you see the files for the 60 images that I took. And again, these were 60-second exposures. My apologies that the cursor's not showing up, but if you look at the frame on the left side of the screen, you can see the raw images. Now as I scroll through them, you'll see that the camera and the telescope move a little bit. The other thing is you see the stars seem to drift a little bit, but the background is kind of a uniform gray. Now the software I'm using to evaluate these images is called Tycho Tracker, and it is developed specifically to identify comets, asteroids, and near-Earth objects, and that's what I use it for. To begin our evaluation of the images, we have to process the images a little bit first. The first thing that we have to do is debayer the images. This was taken with a color camera. It's got a bare filter over it. That causes some distortions. We need to remove that. Then we need to check the exposure on each image to make sure that they're all uniform and even. Then we plate solve the images and align them. And the end result is that we get 60 new images that are processed. So let me show you what those look like. Okay, so now the images have been processed, normalized, and aligned. So as we scroll through the images, you see the stars don't shift anymore. They're lined up one on top of the other. Now it's very obvious to see there's a streak in one of these images, and that probably was a gust of wind that jarred the telescope or something. But overall, everything's nicely lined up. And now what we do is we start looking for moving objects. To do that, we use something called synthetic tracking. Synthetic tracking is under the action menu, and it's actually the bottom one right here. So what we'll do is we'll go ahead and hit synthetic tracking, and it's going to evaluate each of those images. And it's going to compare one to the other along the series and see if there's any movement. If it does identify something like that, it's going to call it a track, and we'll be able to look at each one of those individual tracks. This process takes a few minutes to do, even with a good computer, so I'll be back in a moment. Now, once we've loaded in the star charts and the synthetic tracker has done its job, it's going to identify a series of tracks of potential asteroids. You see those right behind my head. But let's go ahead and have a look at the first track. I've ordered them in order of confidence. You can order them by track number, you can order them by whatever. Now, if you look over in the star field, in the small box in the lower right corner, you'll see what appears to be an object. Now, that's also at the crosshairs. And if I hit Verify Track, I put this all in motion. Now, as you see, the crosshairs are following an object. If you want to get a little better view of it, let's go ahead and zoom in a little bit. As you see, there's an object moving in relationship to the background of the stars. That is indeed an asteroid. Specifically, that is the asteroid Geometra. And if I take the camera off for a moment, you'll see that very first track is identified by name as the asteroid Geometra, and it gives some data on the asteroid. And we come up with a series of observations, and here they are right here. Then what we do is we go over to the Minor Planet Center at Harvard. We click on the Observer tab, and we go down to Other Observer Services, and we go to MPC Checker. And here is the MPC Checker. Now, we'll go ahead and we'll paste our observations into this box. I've got my observatory code down at the bottom here, and we're going to go ahead and click Produce a List of Potential Asteroids. So what it's doing is it's looking at my observations right now, and they're seeing if there's a known asteroid at that location. And here's the output from the MPC Checker. As you can see, it's got my observation, And then right underneath it, it's got some potential candidates for an asteroid. If you look at this, the very first one is Geometra. And if you look over where it says offsets, in right ascension, I'm dead on the money. And in declination, I'm dead on the money. Another candidate would be 2006 YO57. But as you see by looking at the offsets, that's supposed to be a slightly different location. The one that closest matches my observations is the asteroid Geometra. Now, another interesting thing that we can do with the raw data is we can actually scroll through all of the images that show that asteroid. Let's see if it consistently shows up. So we'll scroll through. And it's consistently showing up. The reason that we do that is to see whether or not it's an artifact. The other thing that we can do is we can actually change the way we look at this picture. So by hitting display, I can invert the colors, or I can put a false color in. And then once again, we see that the asteroid is indeed moving. There's another feature right here that we can kind of isolate the asteroid a little bit. Again, to verify that it's a real object. Now, one thing you may notice if you look very closely is that asteroid is varying in intensity. The reason for that is an asteroid is not a cue ball that has a uniform surface color. It has little valleys on it, some hills, it has some area of dark rubble, some area of light rubble. And as it rotates, as it goes around in the orbit, different surfaces of that asteroid will be exposed to sunlight. And as a result, varying amounts of reflected sunlight will reach my telescope. Something that you can do with this particular program is called photometry. And by measuring the variation of that cycle, you can actually measure the rotation of the asteroid. That's useful in helping to identify an asteroid. If you have two asteroids that are similar to each other in appearance and in location, one may be rotating every 12 seconds, the other asteroid may be rotating every 32 seconds. And those rotational periods are known for known asteroids. So that may be able to help you decide which one is which. Now, if we go through a couple more of these, we'll see that others are asteroids as well. Here's the third track. That was the second. Here's the third track. Let's go down to a lower track. There's another one. Now that one's a little tougher to see. So let's go ahead and maybe change the controls a little bit and the intensity and see if we can bring that asteroid out a little. You can barely see it right there, but if we go over to this view, you can pretty clearly see the asteroid. Now contrast that with a probability of none. This may be a false positive. I don't see anything in the crosshairs of that display. And if I change it over to a different view, there's a question of whether or not there may be something there. I don't really see anything there that I want to hang my hat on and make a call for. Compare that to this stack, and that is an asteroid called 2001 RE77. Now, one neat trick that you can do on the Minor Planet Center website, you can generate an observing list. In other words, you put in your latitude and your longitude, and it'll give you a list of asteroids that should appear in your sky, and it'll give you directions as far as right ascension and declination to point your telescope in order to be able to see those asteroids. Now, another thing that you can do is you can go to the JPL Horizons website, and on it, if you click home, you'll get this screen. So what you can do is you can type in the name of an asteroid. Let's look at Geometria. And here's all the data on Geometria. You can see all of the orbital elements, but more importantly, by hitting the orbital view right underneath the name, you can actually pull up the orbit of Geometria. And there we go. So this is what is known as a main belt asteroid. Its orbit is located between the orbit of Mars and the orbit of Jupiter. Some asteroids orbit between Mars and the Sun, some even orbit between the Earth and Sun. Other asteroids actually cross Earth's orbit. If you don't believe that, ask your pet dinosaur. Now, the night that I took those images, I was testing out the RASA telescope, and I was testing out the new camera, the ZWO 6200 one-shot color camera. I wanted to see how a color camera did with asteroids. The images that I just took were 1-minute images, and I took 60 of them. Prior to that, I had tried it over 20 minutes just to see how that worked and basically see what happened. This is the results of that session. The very first track that was identified, track number 1, is this track right here. Now, if you zoom in on this a little bit, it really doesn't show too much, but the computer was pretty confident that this was an asteroid track. So let's go ahead and check a different filter. And sure enough, that's an asteroid. However, there's a couple of minor problems with that. First of all, when you make observations of that asteroid that I'm looking at, and you put it into the minor planet checker, you get this message. There are no known asteroids at that location in the database. This is a potential discovery. However, there's one more problem with it, and that is the speed of the asteroid. Maiden belt asteroids have a calculated speed of 1 or less. Near Earth objects move much faster, and they have a calculated speed of 1.5. This object has got a calculated speed of 2.66, which suggests that it's a near Earth object. In other words, we have an asteroid very nearby. So I went ahead and I calculated an orbit of this asteroid. What's concerning to me is that it crosses Earth's orbit twice. Now, I have very bad weather coming up for the next week or so. I'm going to put the orbital elements and an ephemeris in the description of this chat. Now, if anybody out there has a mount that can do steady 1-minute images, and you can take 60 of these images at the location that I'm going to specify, I would very much like to see those. I will process them, and if it shows this asteroid again at a different location, not only will we be able to get a better orbit calculation, I will go ahead and give you co-observer status if it is a discovery. However, I still get to name it after my wife. I need 60 1-minute frames of this asteroid, and I need to know your location and what equipment you took it with. I will process the images. Let's see if we can characterize this a little bit better. This could be an artifact. It could be an asteroid. My original orbital calculations were very limited. I need to get a better orbit on this asteroid. This has been reported to the Minor Planet Center, but I need more follow-up observations to be able to nail down that orbit a little bit better. So help me out here. In the meantime, this is Bob the Science Guy signing out from Northern Michigan. Thank you very much for your help, and I'll see you again soon. Clear skies, everyone.
Mama, please make them hear me, or I can't teach them anymore. This rabbit hole's too deep for me. Feel my brain getting real sore. Bob the Science Guy. Bob the Science Guy.